It's my great pleasure and great honor to welcome here Richard Yonck, who is well-known futurist, author of several books like Future Minds. And he was so kind that he accepted my invitation to give a lecture about topic which is very hot in the area of AI. What will happen with AI in the future? What about the consciousness? What about other aspects of AI? And I think it's quite important topic for people who would like to work in this field, but who also think, for instance, about impacts of AI in the society, to the society, which think about future trends in AI research, about the limits of machines. So I don't want to spend a lot of time. I think it's not necessary to introduce Richard Moore. Just he is traveling around the globe and gives lectures at such universities. Maybe you have heard about MIT, for instance, and today he is at CIIRC CTU sharing his experience with you. Richard, it's your floor is yours.
Thank you so much, Dr. Merrick. It is my pleasure to be here today to see all of you and to have this conversation about the future of AI, machine consciousness, and the future of human intelligence as well. This is a topic that I've explored at quite a bit of length through the years, and it's a great opportunity to be able to share it with you. We'll have at the very end a question and answer session. If you want to save some questions for that time to have a little bit further conversation around some of the things we're going to talk about. Now, today I'm going to cover a lot of material, but one of the things I'm also going to do is to challenge some of the assumptions and narratives that have developed around artificial intelligence, because I think that this is very, very important to how we make decisions going forward around this subject. It's an area that there's a lot of misinformation about, and an area that there's a lot of different ideas and opinions around. So there's a lot to cover, so let's get started. So to begin, everything we're going to talk about today is pretty much related to the idea, the topic of intelligence. Intelligence is something that we use and throw around as a term very, very freely. It means many, many different things to different people depending on what's being spoken about at that given time, who's doing the speaking, and it's really worth noting that it means so many different things. So much so that many years ago, the AI pioneer Marvin Minsky coined the term suitcase word, the idea that certain words, very often words that have to do with our subjective experience, tend to be used in all kinds of different ways. They tend to have very amorphous definitions. So a few years ago, I wrote a book titled Future Minds, The Rise of Intelligence from the Big Bang to the End of the Universe. No small topic there. And in approaching this, one of the things that I wanted to begin from is, if in order to understand where intelligence is going in the form of AI and machine intelligence, we first need to really understand what is it we're talking about? What are we trying to define? So about almost 20 years ago, a couple of researchers, Shane Legg, who went on to be one of the founders of DeepMind that became Google DeepMind, and Marcus Hutter, did a series of research papers around trying to define intelligence. And in doing so, they came up with approximately 200 different definitions around this word. And it really runs a spectrum from people who talk about it in very, very abstract terms, in terms of the kinds of ways that many people think of intelligence in terms of it being about abstract thinking and being able to solve complex problems, and for some people to be able to play chess and other such things. It's a great definition, but unfortunately, it pretty much eliminates almost every other species and maybe even some people from the definition, which isn't really what I was looking for. I was looking for something that would encompass many, many more types of intelligence. The other end of the spectrum was Stephen Hawking, who spoke in terms of AI being about, about intelligence being about the ability to adapt to change. And that's a very much broader definition and explanation, but it also goes beyond animals. We could apply that definition to a thermostat or a thermometer. So in some ways, that's a little too broad. What I wanted was something that it encompassed the many different features of the universe that lead to this almost inherent property of being able to bring about self-organizing forms of complexity that lead to emergences that become different forms of intelligence in our world, in our universe. So we go from chemistry to biology to early organics to proto-life to single-celled organisms, eventually to complex organisms, and eventually human beings. So in order to get to this, I'd coined a definition based on some work that was done by a famous physicist. The idea that intelligence is an emergent system's ability to respond to its environment in order to improve its conditions, perpetuate itself or its species, and maximize its future freedom of action. There's a lot of things that can be discussed here, which we won't cover today, that go into differences between determinism and free will. But this definition allows us to talk about intelligence in a fairly broad sense, so that we can say that everything from a cell to a plant to various forms of animals to ourselves all bear certain kinds of intelligence. The question becomes, can we apply this to machines? Can we apply it to AI in the future? And is it already here? Do we already have intelligent machines? Or is that somewhere in the future? Or is it even possible? So ultimately, when most of us talk about intelligence, we're thinking of human intelligence. We're thinking of consciousness, which is almost a holy grail, talking about what intelligence means to us as human beings. It's our internal lives, our self-awareness, our experience of the world. That is something that in many respects, artificial intelligence, as so far as we know, doesn't experience yet, isn't capable of at this time. The question becomes, is it ever going to be possible? Is this something that we can look ahead to, where we can get to a point where artificial intelligence actually understands its world, actually is able to experience it and to internalize it in ways that are similar to our own? That's a very different kind of question, but I think it's an extremely important one for the future that we're building. So the possible answers are, of course, no, absolutely not. It's not possible. It may be, some people will say, yes, absolutely. And then for many other people, it's maybe it's possible, but how can we ever know? This is what's in philosophy is the solipsistic argument. It's the idea that, can we ever actually know what is going on in the mind of another being? So it's very challenging to think ahead and say, well, is AI going to be able to emulate this, or is it actually going to be able to experience it? So that's a really important area to be exploring as we talk about this going forward. And ultimately, why are we doing this? Why are we building AI? Why are we creating this in the first place? Well, to my mind, one of the important areas is interfaces. So since the beginning of the computer age, we've been building more and more complex interfaces. We've had hardwired interfaces, the command line, punch cards, graphic user interfaces, more and more visual interfaces. These have all been ways that we interact with our devices, our computers in more and more natural ways over time. That's extremely important because instead of it being limited to something that only computer scientists, very specialized people are able to use, instead it becomes something that's much more accessible to everyone, such that today we are in the era of natural user interfaces, touch screens, voice commands, gesture recognition. All of these are a way to interact with these computers that was never possible early on, but we have the processing power and the know-how to be able to make this happen now. Looking ahead, what are the next interfaces? What are the easier ways that we're going to be able to interact with these devices? Because right now, we already now have a means by which even a child can pick up a smart pad and begin playing a game or what have you. It really democratizes the technology in a way that it never had been early on. So, to my mind, we're building a lot of this to increase our ability to be able to interact with these devices in ways that are more and more useful to literally everyone. The idea that ultimately AI will be a colleague, a companion, a mentor, a confidant, these are all very, very important and possible futures for where this is going to go. But it also raises many potential issues in terms of privacy, in terms of who is accessing and utilizing this knowledge. What happens when you have an AI companion for a decade of your life and suddenly the company goes out of business? These things are very real considerations. So today I want to, among other things, challenge a few of the assumptions and narratives we have with regard to artificial intelligence. I talk about this ideas like the Silicon Valley narrative, the idea that many people in certain parts of technology have been perpetuating for decades now, that artificial general intelligence or AGI is inevitable, that we will almost definitely have brain computer interfaces, all kinds of different things that, yes, they're very possible, but there are also reasons to think they may not be either feasible, possible, or ultimately desirable. So let's start with one of the first that I like to talk about, which is people's comparison of a transistor and a neuron. This is something that is a very easy analog to make. They're very similar in certain aspects of their function, a certain kind of signal switching that takes place. So it's easy to say, oh, these are equivalent. This is, if we just put together enough transistors, we'll be able to achieve something like an electronic brain. And as we drill down, there are still similarities in terms of how they connect, how they layer, in order to make them usable, they have to be effectively interlinked. But as we continue down, something changes that is going to affect the emergence of what we call mind. Mind emerges from these functions of the brain. And when we go all the way down, we see that really a transistor and the inner workings of a cell are so vastly different in terms of their complexity by many orders of magnitude that we already know that to be able to do very basic visual recognition with AI, that it takes on the order, based on some studies, of 1,000 virtual neurons to replicate a single natural one. That's just for that particular purpose. So to expect that we're going to see the same kind of emergences from this that occur with putting cells together is probably a really big jump, and one that I have to question a lot. The same goes for how this applies to other technologies, when we talk about artificial intelligence being able to somehow join biology and electronics, we get to, of course, the idea of computer uploading of our minds, having brain-computer interfaces, ideas like this. This is also possibly a myth, possibly a narrative that we really should be questioning, because there are many reasons why it could be desirable, but we also have to ask ourselves, is it desirable? Ultimately, though, is it even possible? There was a study a few years ago in which language was studied. They looked at many, many different kinds of languages and came to the conclusion that the maximum rate of transmission that was occurring in every single language was on the order of 39 bytes per second. Now, if you think about that, that feels like that's a top limit, the way that that's happened across all kinds of cultures and languages. If that's the case, the idea that we're going to suddenly have electronic learning that is easy and rapid would seem to be highly questionable, because ultimately there may be top end limits. Even if we can decode the language of the brain so suitably, there's probably top end limits to how far we can go with that. Another Silicon Valley narrative that has been going on very prominently lately is that of AGI, or artificial general intelligence. The idea that at some point a super intelligence is inevitable, is going to arise out of all of this, and is going to lead to either, depending on who you speak to, a nirvana or a rapture, or to something horrific. The problem with this idea is it assumes that this is a trend that will go on forever, this exponential growth of capability of self-improvement on the part of these parts of these machines. That we really, I think, should be questioning a lot. It's at this point in time very much in the benefit to the benefit of various companies to promote the idea that they need to protect us from artificial general intelligence, that it's inevitable. We've had people like Sam Altman and others tell us almost every year that it's going to happen in one more year. It's just around the corner. I think it's a lot further away than that for a range of reasons. And when I talk to people in different labs, a number of them do believe this. Some of the people working in artificial intelligence in the form of AI, generative AI, perhaps think otherwise. But we have a lot of reasons to say that some of the generative AI is perhaps not as capable as some people want us to believe. Large language models took off 3, 4, 5 years ago. They originated out of a paper that came out of Google in 2017. And for some people, this is the new path to AGI, to artificial general intelligence. The problem is that that's not what these systems do. These systems aggregate information in a way that we haven't been able to do before, but this is not the same thing as having the understanding of what that information is about. We started a number of years ago, these companies, by taking vast amounts of text, of writing, of books, of different information that we've been all pouring onto the internet for the last 30 years and more, and putting it all into an enormous corpus that a transformer model then operates on. It is an incredible tool. It's something that suddenly seems to be capturing the imagination, not least because of the new interface that allows almost anybody to sit down and instantly use it. Some of us better, some of us worse, but the point is that it seems to do amazing things. It almost seems intelligent. And the reason for this is because It's us. We've been pouring ourselves onto the internet for all of this time, and it's reflecting it back on us now almost as a mirror. This is the thing about human evolution. We developed through history, through the millennia, to anthropomorphize. We tend to look at aspects of nature, and as part of our own consciousness, we tend to ascribe consciousness, agency to other things in the environment. This is actually really, really important. It helped us to survive. It's beneficial to assume that something is smarter than it actually is rather than the other way around. But the problem is that we're entering an era now where this could also get us into a lot of trouble as well. So we get to a stage now where more and more people are believing that what they're dealing with is something that can genuinely think, that is an actual person, as we've seen with different employees of different organizations, companies in recent years. Uh, there have been people who are convinced that they're talking to a human being. Now, for any of you who, most of you are too young to remember, but back in the 60s, we had Eliza. It was a early chatbot, one of the very first chatbots. And Eliza was very capable at interacting with other people, with people as a therapist, and people believed that that they were actually interacting with another human being or something that had consciousness of some sort, even when it didn't. That is something that has been going on for a long time, but it's going to become more and more prevalent in the coming years as these systems become more and more complex, as they become more and more capable of convincing us that, whether intentionally or unintentionally, that there is actually something there, that there is actually a thought process behind all of this. Some people talk about LLMs and other forms of generative AI as being alive, but really what it is it's a new form of information management. That's what this truly is at this stage in our technological development. It's not We're not creating yet something that is capable of understanding what it's talking about. It simply is sending back to us things that we've been ourselves generating all this time. But it does raise the question, what happens as these tools become so capable that we aren't able to determine whether they're real or not, whether there's real thought process going on, whether there is a real ability to think, to perhaps even suffer? That's very concerning, but it also is, to my mind, a much bigger issue in terms of what it means for people and how people utilize AI to their advantage, taking advantage of other people. 2017, Google came out with a famous paper that drove all of this. Attention is all you need. Now, the problem with this is it's a great idea. It got us through into the generative AI period, most definitely. But it's not all you need. It's what we needed to get to this stage. But to be able to get to the next stages of intelligence, we have to consider that human intelligence evolved over, for ourselves as a species, hundreds of thousands of years, and for biology in general, 500 million years. The different areas of our brain evolved over a great deal of time and were not initially integrated. Over time, though, many of these regions did integrate. And so you have a number of people who believe that the future of artificial intelligence, of AI, is the bringing together of many different modules, different areas of thinking that can be incorporated together. And as these merge, perhaps there is a possible future consciousness that can come out of this. But ultimately, it's about recognizing that one single approach isn't probably going to get us there. And we'll talk a little bit about in a moment about what areas are being worked in with regard to that. We do have an AI alignment problem, though, and this is real, not least because everything that we're developing right now is, as it gets more and more powerful, more and more intelligent, we need it to reflect human values. We need it to be able to operate in a way that makes it a good tool for us rather than doing something we don't want it to do. To be able to do this, we have to have it reflect the kinds of values that we have. I've been writing and talking about artificial emotional intelligence or emotion AI for a long time. And that is essentially the systems that can read, interpret, and interact with human emotions. I wrote a book a number of years ago, almost a decade ago, about this that looked at how this came about, why it was important to the future of artificial intelligence, and ultimately recognizing that emotion is probably the most core aspect of the human condition. This is something that we developed long before we developed uh, our ability to speak, our ability for complex language, certainly any of our technologies. Emotion was there before all of that. And that is something that if you study how we use emotion, a lot of it has to do with our placement of value. What in the environment needs us to pay attention to it at this time? What is important? What is threatening? What do we look ahead to that might be important? All of these are driven by our emotional responses. This is something that AI does not have access to yet. But at some point, if we can figure out how this can be built into it, it could help us to be able to align AI with the ways that humans think and value the world. So there's a whole range of reasons. This has been a field that has developed slowly. There are a number of pushbacks around what can and can't be achieved with regard to emotion, artificial emotional intelligence. But one of the things I tend to believe is as we move into an era of more and more reasoning on the part of AI, as it begins to have more capabilities, that ultimately it will allow the machine to be able to do something we do very naturally, which is called theory of mind. When we talk to each other, when we look at each other's faces, when we hear each other's voices, we're continually forming a picture in our minds of what do we think the other person is thinking. And this is a very important part of our ability to align with each other, to be able to communicate and so forth. And it's something that AI does not do at all yet. But if we can get it to that point, it will go a long way to helping us to align with it. In terms of AI's ongoing hurdles, there's different research being done around the world in a range of different areas. Some of this is already well underway. Things like spatial computing, machine common sense have been going on for some time. Other areas are relatively on the horizon. But ultimately, they're going to all come together as these different modules or these different areas of AI, in my mind, to be able to form something that is more and more capable, thinks more and more like we do. Ultimately, though, one of the areas that's going to drive a lot of this is embodied AI. If you think about how we experience the world all the way from the time we are a very small child, is through the exploration of our environment, the ability for us to go through it and fall, to see things happen, to interact with other beings. An AI that is currently basically locked into a digital domain that doesn't have this experience of the world is learning and acquiring information in a very, very different way. And in order to properly align, I do believe that ultimately having this kind of interaction is going to be essential to the education of that future artificial intelligence. Of course, we're already in the era of agentic AI or AI agents that are becoming more and more capable of doing different tasks for us, do different things that we would ordinarily have needed to do ourselves. Some are more capable than others, but in time, this is all going to feed into this system such that it will help to further educate and take the artificial intelligences to the next level, the next step. Hybrid intelligence, let me just see where we are here. We're close. Hybrid intelligence is an area that I think is going to be driving the next several decades of human and artificial intelligence interaction, because there's been a lot of concern about what's going to happen with jobs, with employment, and so forth. I don't think that AI is anywhere near close to being able to take over most jobs. It can do many, many tasks, though. So if we can utilize it in a way that essentially makes it into a coworker for ourselves, this goes a long way to being able to help us, but also to help train it over time. Ultimately, all of this is about trying to figure out how can we work best with the technologies that we have been co-evolving with over these many centuries, such so that we eventually can build a world that is the kind of future, the kind of world that we all want and deserve. And with that, I open the floor to questions and answers. Thank you so much for listening.
Who wants to start with questions? There were many motivating sentences. Please.
How the I mean, consciousness is hard to define, but in the area of, let's say, some experimentation, is there some experimental test that can prove that there is a path when solved with the consciousness and without the consciousness, that the consciousness is beneficial? Is there such a test or some experiment that will prove such a thing?
There is no single test. There is no single test, to my knowledge, that could begin to do that. For some time, there has been an awareness test that's referred to sometimes as the mirror test, that a small child is able to understand or recognize what a reflection of itself is at a certain stage, that this indicates a certain development of consciousness. It's actually been applied to certain animals that have also been able to recognize this. It's not, first of all you can say in many respects that the consciousness of different species is on a spectrum just as intelligence is. There, in many respects, we tend to separate intelligence and consciousness, but really it's all part of the same thing. We ultimately have the minds that we have because of the species we are, because of the ecological niches that each species has come to be optimized for, to exist within. So to answer your question more succinctly, I guess I would say that there is not a single test at this time. And because the nature of mind is so subjective, it is really hard to get to the point where you think that is going to be a I'm not sure that's possible. Have people seen the movie from about 10 years ago, Ex Machina? Okay, that artificial intelligence was put forward as to suggest that, okay, is this or is this not an actual being that is experiencing? And the problem is that it's left very, very open. In my mind, the way that the director handled it, in fact, it actually was not it easily could have been a machine that was simply going through the motions to convince the humans in its environment that it was suffering and needed to be released. And this is a problem going forward, as I say, when we think, well, there's actually experiencing an internal life and there's convincing people that you are. So it's fine for human beings. We can pretty much assume we all are conscious, but it's another thing to say, just because a machine tells us it is, does not mean it is. Hope that answers some of the question.
I'm interested in your.
I'm sorry, I can't hear.
I'm interested in your way to describe neurons because your analogy with transistors is why not? But I have heard also about analogy with op amps because I saw video on YouTube where the YouTuber told that a better way of computing and producing artificial intelligence might be using op amps and analog computers because he told that several applications of the artificial intelligence is done with metrics and their multiplication.
Okay. One word I'm missing that you're saying is I'm hearing amps or ants or what is the word?
Op amps.
Amps. Amperage?
Operational amplifier.
I actually can't give you a good answer for that. There are many different approaches and ways that we could be approaching this. The people have talked about analog computing, going back to some of that technique. I can't actually say that I can give you a very informed answer to that one. I like to try and answer everything, but I actually don't have a good one for that. If you want to explain it further, that's fine, but I don't think I can give you a response that would be very informative. I'm sorry.
Okay, thank you. I will have to figure it in my right.
Yes.
Jakub is our secondary school student who is with us for 2-week internship. So his age is 16. Okay.
Okay. Well, so nice to meet all of you.
Thank you for the talk. And you mentioned the large language models in one of the slides. So, and if I understood correctly, you said that what the large language models they are doing is basically they are not understanding, but they're aggregating. They're aggregating the data, and this is basically their response. And if I understand you correctly, you mentioned that this is not like a true understanding. This is just an aggregation. So my question is, what does the understanding means personally for you, or how you will define it in comparison to the human intelligence?
Sure. It's a good question. I think that when we talk about our comprehension, our understanding, our reflection on anything that we take in, the question you've just asked, the conversations we have with each other, having a number of the elements that I was talking about with regard to human consciousness previously go a long way toward enriching that, making that much deeper in terms of our having an understanding, a comprehension. If I understand that if I take certain actions that they will lead to certain other events, that this is all part of our experience and our learning of the world. If all that a system is doing statistical work on a series of text, a series of language to be, or in the case of images, to be able to put it together in new and fairly novel ways. This is a really good tool, but it's still just statistical aggregation. It's not, there's nothing there internal to do the understanding. If it gets to the point where there's an internal world, a consciousness, I know that again, there's the word. It's so nebulous in many respects, but it is important to recognize that it's going to take a lot to get a machine to have that, because our intelligence, our brains, our neurons, 86 billion of them had to come together and generate an emergence that we call mind, that is something totally unique in the universe. There are other minds, other intelligences in other species, but ours allows us to view and reflect and question the universe in ways that nothing else can at this time. It's possible that AI can get to that point, but I don't think it's going to be enough that it's just going to be scaling up an LLM. So I hope that addresses some of it, but it's not again, when you're talking about consciousness, it's really hard to say at what threshold does it occur. Will we know when AI has reached that point?
Maybe, sorry, if I can a little bit reformulate. it.
Please.
So you mentioned this aggregation, like, for example, we have some simple statistical data, some table, and we aggregate, we compute mean and average and whatever. This is a really simple aggregation data. Yeah, that's
But
then you mentioned this attention is all you need, this paper.
Mhm.
And this is in fact also the aggregation, but in a much more advanced way, right?
Yeah.
So you're selecting. So well, my question is that whether you think it's possible that when we will be when some smart LLM techniques of more smart aggregation will appear, and they will appear, whether it will be an equivalent, whether you think it will be an equivalent, or it can be an equivalent for a human way of understanding.
again,
If we will improve the aggregation to the extreme, right? So
right.
this will be a very fancy technique.
I think we can say that any technique can be scaled up, but does that take us over a certain threshold? It's certainly not how the human brain performs these things, and it does it with the equivalent of a 30-watt light bulb in terms of energy versus needing a nuclear power plant to be able to operate it. The amount of energy that's going into all of these different forms of LLMs these days is phenomenal. If we keep scaling it up, there comes some point where that's just not feasible to continue. But to answer your question, we have ideas like RAG, which utilizes reinforcement learning and other input to be able to inform the LLMs to get to better answers. But that's still about using statistics, using information to supplement other information. That's not the same as the inference, the creative and abstract ways of thinking that we do at this point. Can they do amazing things? Yes, but it's because we've created an entirely new tool that is able to interact with our information in a way that we've never been able to before.
Add something. If we are talking about large language models, they will be improved, they will have better performance, but all the time it's just emulation of the activities of the brain. But once we would like to talk about consciousness, we need to have to reach simulation, there should be internal observer, and the machine should enjoy what it is doing, yeah, experience and whatever. So we need to cross the borderline between emulation and simulation, simulation with internal observer. What's your opinion? That's my opinion, and I would like to.
It's a wonderful question, Doctor. And to my mind, I've thought for a long time that that is how we will get to something similar. I don't know that we can get to the exact equivalent of what human beings do because it starts from such a very, very different substrate, but because biology versus silicon. But it is likely that we will continue to develop to the point where there's something that seems similar, but the question then becomes, can we prove it? Can we prove that it has the internal experience that we're saying? You and I have it, but just because the machine tells us this, already we have different bots, different LLMs that tell us different things about their intentions, their joys, their what is important to them, whether they want to take over the world or not. We've had all kinds of stories around this in the press. To my mind, it still remains a question. Can we ever know?
Really, this is a good question because even the machine can simply emulate our feeling and say, I'm enjoying it, but how to prove it? Because consciousness is very subjective matter, you know. So I don't want to spend more time by my questions. You would like to?
Not at all.
To study such a phenomena that when you can't find the area, you can know and briefly test or I mean having this phenomena is beneficial and you can so where to find the motivation to study this area?
To my mind, the motivation is that we are an incredibly curious species, and if it's something that fascinates you, this is how our entire civilization advances. I think if it's an area that means something to you, that this is a phenomenal area to focus in. Philosophers, psychologists have studied consciousness for millennia. They've asked questions about it. They've tried to test it. Just because we can only learn up to a certain point doesn't invalidate it. And certainly, just as we have some basic tests today to be able to test for certain types or aspects of awareness, there may be other things that other people, including perhaps yourself with your future studies, might eventually develop. So to my mind, this is how knowledge builds, is that we're just such an incredibly curious species that somebody or another is going to inquire and ask and eventually answer. So I hope that answers your question, and thank you. Anybody else?
So my question may be the last one, but still you are invited to put questions. What about Kurzweil singularity? Do you believe that we will reach it one day, or whether it's not reachable at all? So simply, what's your opinion concerning this issue?
Thank you so much. And yes, it's a question I do get asked semi-frequently. Yes, it's Ray Kurzweil, who reviewed my first book, is famous for bringing up the singularity because he wrote a book titled "The Singularity is Near." The topic was actually goes back to, I think, some scientists back in the 50s, but it was popularized in the early 1990s by a paper by the science fiction writer Werner Vinge, who I interviewed a number of years ago, who basically explored this idea that at some point, artificial intelligence reaches the stage where it is able to self-improve itself, to be able to achieve something a little more than it was before. And then it takes that a little further and a little further. And we get what the people who talk about the singularity refer to as an intelligence explosion, a sudden existence of an AI that is as intelligent as a human being, then as intelligent as all human beings in the world. There are arguments for and against this. For my mind, it's the recognition that just about every single phenomena in the universe has some level of limiting factors, whether that's energy, other resources. There's only so far you can take certain things. So that makes me question it at one level. At another level, I think that we have to recognize that it's an important question, one that we have to try to be prepared for. But the idea that we're at a stage where someone like Sam Altman last week is telling the press that we're going to build a bunker and go into it before we release the AGI just in case, is a really questionable strategy on all fronts. I think it's much more about PR and trying to convince the world that it's just around the corner. I think that it's a long way off. I don't believe that it's going to be 2045. I think that it, as Ray Kurzweil has said for so long, um, you can talk about exponential growth, the idea that things develop faster than we expect. But what I see continually with technology and artificial intelligence in general is that it's easy to do the first 90%, comparatively easy. We get to the last 10 or 5% and it gets really hard. So we've been talking about, we had car executives saying we were going to have the roads filled with self-driving cars by 2017. At this stage, it's going to be at least 2030 and beyond. It's not, yes, we can do it in certain limited and controlled fashions, but putting cars out in the road to interact with people and other vehicles in most urban environments is much harder than a lot of people think. So we're getting there. The technology is definitely developing, but there are still a number of percentages to improve. And unfortunately, even if it's 99.9% efficient, that's not always good enough. So ultimately, sorry, coming back to singularity, I think we're further out than they talk about. I think we eventually get to something similar. Is it result in something dangerous? Perhaps, in which case we have to be prepared.
Okay. Okay, thank you for this answer. Please, still there are chances for questions.
I'm sorry, for AlphaFold? Alpha Evolve. Okay. Mm-hmm. Live code, yes. Mm-hmm. And this is a, I'm sorry, I thought you were. Mm-hmm. It's there. Mm-hmm. I think that it's an ongoing progression that we've seen going on for a long time. Well, long time, years. So different forms of evolving algorithms, evolving, um, uh, blanking on the term I'm looking for, have been developed since good 50, at least 15 years ago or more. This is a next stage. There are things in programming and in technology, well, AI, that are called perverse instantiation. And this is the idea that when you have extremely complex problems, that we tend to get artificial intelligence creating answers that maybe are optimized, but aren't necessarily optimized for our purposes. So we have to be very, very careful about how this develops. We can't just simply say, this is going to be the answer. I think it is an important part, but I think we have to be in the loop in order to be able to oversee some of that. So I think it's coming, but I don't know that it's quite here yet. I know that we're getting close, but I think it's still a couple of years on the to really get the self-driving cars where we need it to be. Yeah, I will be watching. Thank you. Miles?
Thank you. Please.
Is currently challenge in terms of AI. I know it's very general, so maybe some interest gains or something.
I think there are quite a few. Ethically and legally, I still feel this is just right off the top of my head, and I know there are more serious things, but the issues around intellectual property and the acquisition on the parts of these companies to take information, take works that human beings have created, whether it's art, novels, books. All of these are things that we put a lot of time into to create. There have been reasons that we have tried to create certain kinds of protections around this. That's part of our current copyright and other types of intellectual property protections. There are arguments that maybe all information should be free, but that's not where the law stands right now. So there's a whole range of issues going on with the likes of Facebook and so forth who have acquired this information and are making the argument that, well, those works have no intrinsic value. Well, that seems really questionable logic or justification. In terms of other areas, certainly things like self-driving cars. If a self-driving car hits somebody, is the occupant responsible? Is the company who created it responsible? Is the intermediary company that was responsible for certain update getting to that car responsible? There's going to be so many new issues of legality and liability in all of these areas. Um, and then we have things like social media that is incorporating artificial intelligence more and more. We have people who are being directed to information that is detrimental to their mental health. How do we protect them? Are the companies liable for that exposure? All of these things I think are very, very new horizons we have to look at and approach. So it's going to be a lot of things.
Just small comment. Next Thursday we will have a conference here on AI and law. So there will be probably some answers to your question also given from the point of view of Czech legal system.